One of the fiercest debates in quantum computing right now is timeline to real-world impact. And Google is out with a new countdown that will excite the enthusiasts.
October 22nd, 2025 changed everything. Google just achieved something that physicists have been calling theoretically impossible. This happened thanks to Google's quantum computer, which cracked open a 50-year-old physics mystery. If you want to stay ahead of the computing revolution, hit that subscribe button right now, because the world is moving too fast to miss even a single update.
1,000 times faster, not faster than your laptop, faster than the world's most powerful supercomputer. Google just crossed a threshold scientists thought was years away. A problem that would take years was solved in just hours.
The breakthrough. Google's Willow quantum chip just demonstrated the first ever verifiable quantum advantage on hardware, running 13,000 times faster than the world's fastest supercomputers. However, that's just the beginning of the story. Here's how it happened. The chip performs a computation in under 5 minutes that would take today's fastest supercomputers 10 septillion years, which is a 1 with 25 zeros to make things interesting. In other words, the universe is only about 14 billion years old. This computation would take longer than the age of the universe, and then multiply it by 700 trillion. But wait, there is something even more mind-blowing. At the same exact time Google announced this breakthrough, researchers at the University of Stuttgart in Germany published their findings that fundamentally challenged a 200-year-old law of physics. They proved that the quantum systems at the atomic scale can now exceed efficiency limits defined by the Carnot principle, which has remained unchallenged since 1824. For people who don't know what this means, let's just think about it for 2 entire centuries. We've designed every single engine, every motor, every power system based on thermodynamic limits that we thought were universal laws of nature. We had steam engines, car engines, power plants, computer processors, and all of them were supposedly bound by the Carnot efficiency limit. Now those rules just got thrown out of the window at a much higher level, which is the quantum level. This isn't just a technical achievement. This is nature revealing what she's been hiding for centuries.
A real-world problem that a quantum chip actually solved. A proof point, not just a promise, giving the technology tangible weight.
The Willow chip. Let's break down what's actually happening inside Google's Willow chip, because that's where things get wild. The Willow chip features 105 qubits with the fidelity of 99.97% for qubit gates, 99.88% for entangling gates, and 99.5% for readout. For those who don't read quantum, let's just translate. That's like having a supercomputer that makes only 1 error for every 10,000 operations while working at speeds that are measured in nanoseconds. But here's where things get crazier. Willow can now reduce errors exponentially as more qubits are added, while cracking a key challenge in quantum error correction that the field has pursued for almost 30 years. This is huge. It's like building a car that gets safer and safer as it goes faster. It's almost like it's basically AI. Every previous quantum computer gets more error-prone as you scale it up, but Willow did the exact opposite. The real breakthrough comes from what is called the quantum echoes algorithm. This technique works by sending a carefully made signal into the quantum system of 1 qubit, but then precisely reversing that signal's evolution to then listen for the quantum echo that comes back. In other words, it's like creating a quantum butterfly effect inside the processor, then running time backward. If you're wondering what this is, it's not just science fiction. It's happening right now in Google's laboratories. They're literally rewinding quantum information like a tape, measuring how disturbances go through the entire system. This then lets them extract important information about molecular structure that would be completely impossible to see in any other way.
Introducing our latest quantum computing chip, developed to learn and evolve like the natural world around us. Willow, from Google Quantum AI.
Breaking the laws. In hindsight, here's where it connects to something even bigger. While Google was demonstrating quantum supremacy, researchers in Germany were proving something that should be generally impossible according to classical physics. The Carnot principle was developed for large macroscopic objects like steam engines, but researchers have already proved that it must be extended to describe objects on an atomic scale, particularly strongly correlated molecular motors. But what does it actually mean? In classic thermodynamics, there is a hard ceiling on how efficiently you can convert heat into work. It's called the Carnot efficiency, and it has been considered an absolute limit since 1824. So here's the formula about that. The higher the temperature difference between hot and cold, the higher your maximum possible efficiency is. Every engine ever built has been bound by this limit until now. Researchers discovered that these thermal machines that are functioning at the atomic scale are capable of converting not only heat, but also quantum correlation into actual usable work. This allows the overall efficiency to exceed the conventional coronet limit. They are tuning the weird properties of quantum entanglement into actual usable energy. This works because at the quantum scale, particles become correlated in ways that deny classical physics. These special bonds formed between particles on incredibly small scales now create resources that classical thermodynamics never really expected. For the first time in human history, scientists have discovered a generalized law of thermodynamics that fully accounts for these correlations. Well, we have already talked a lot about what scientists have been cooking in the lab thanks to Google's new chip. What does this actually mean?
With Willow, we've made a huge step forward. We've increased quantum coherence times by a factor of 5, going from 20 microseconds in Sycamore to 100 microseconds in Willow. And we've accomplished this all without sacrificing any of the features that made our systems so successful.
The application? First, drug discovery has become better and faster than before. Right now, developing a new drug can take at least 10 to 15 years and even cost billions of dollars. However, with quantum computing, they can simulate a molecular interaction that would take classical computers centuries to calculate. Google demonstrated how its quantum equals algorithm can measure longer distances between atoms than any of today's methods available. This way, they can gain more information for understanding complex molecules that are crucial for developing new medicines and materials. This destroys, and this completely shortens the development timelines from years to months. Personalized medicine also becomes feasible when you can model different individual genetic variations in real time. Let's say someone has a very rare disease. Using the power of quantum computing, their specific row or other specific issue can be solved so much more easily. We're even talking about designing drugs that are cell-tailored to your specific DNA, simulated and tested virtually before a single molecule is even synthesized. On the other hand, material science gets a complete makeover. If you want a room-temperature superconductor battery with 10x current and energy density and materials that don't even exist in nature, then all of these things are possible by using the new Google quantum systems. Advanced quantum computing can be used to accurately simulate small quantum systems, like chemical reactions, that could help us discover new drugs or even solve complex problems to build new types of material energy systems.
A chip the size of your fingernail. 105 qubits, operating at temperatures colder than deep space. This is Willow, Google's quantum processor that just achieved what researchers are calling verifiable quantum advantage. The breakthrough isn't just speed, it's verification.
Will also take huge benefits in ways that we couldn't calculate before. The German researchers discovered something amazing. They discovered that perhaps one day, these quantum motors will power medical nanobots and control machines that process materials at an atomic level. The potential here is absolutely enormous. We're talking about molecular motors that exceed a classic physical energy limit, which enables technologies that seemed like science fiction just months ago. So all the movies and the animated series that you watched where science is heavily involved, those things are absolutely possible. The timeline. But how long till we start seeing results of this new breakout? Well, if we were to talk about realistic timelines, we might need to be more specific with everything. This is because the hype and reality are two different things. Experts say that it's at least a few years away before we reach new kinds of capabilities where quantum computing can be used directly for things that are running our industry. So we probably shouldn't think about getting a quantum laptop next year. Here's what's actually coming. Google has been tracking its quantum roadmap, which was published in 2020. It demonstrated beyond classical quantum computation in 2019, a quantum error correction prototype in 2023, and below threshold error correction with Willow in 2024. Their next milestone is the ever-so-popular logical qubit, which will enable quantum computers to perform complex calculations for an extended period of time. In other words, Google's plans say that their large-scale fault-tolerant machine will appear somewhere around the end of this decade. We can expect between 2029 and 2030. This sounds far away, but in technological terms, that's basically tomorrow, and each milestone is coming faster than the last. If we think about this pattern, in the next 40 years, we can get superconducting qubits to work reliably. It took 4 years to go from quantum supremacy in 2019 to practical application, but now acceleration is getting even faster. The next major leap is going to happen even faster. Within the next 18 to 36 months, we will see quantum computers that can maintain operations long enough to solve real-world problems. By 2028, there will be commercially available quantum services available for specific applications out there. By 2030, quantum classical hybrid systems will become common and perhaps even be available for retail for almost everyone to benefit from. The dark side. However, if all this is too good to be true, maybe some sides are, because there are some uncomfortable truths that we need to address. This technology also has a dangerous edge that keeps security experts awake at night. Quantum computers can theoretically break down modern cryptography much faster, which also poses a major threat to today's algorithms. The same system that will cure a disease can also cause disease in different systems. The same processors that optimize clean energy can potentially break into every bank simultaneously. However, here's the critical caveat. According to Google, the Willow chip is incapable of breaking modern cryptography and quantum technology, with that capability still years off. Experts also suggest that this might be around 5, 10, or even 15 years before they could start doing all these things. The fastest 5-year timeline will require some unforeseen technological breakthrough. However, the fact is, we are still in a rat race. A race to quantum-proof our digital infrastructure before quantum computers become powerful enough to crack everything. The National Institute of Standards and Technology has released many quantum-safe algorithms that are resistant to attack by future quantum computers. In other words, this asymmetry between quantum systems has become a genuine security concern. The organizations are making moves right now to prepare for the quantum threats while also trying their best to survive the transition. Those who ignore it will have a catastrophic future. 2025 was the year of verifications. Here we are just proving that quantum advantage is real. It exists, and Google just demonstrated it with the quantum echoes. Others will follow with their own level of understanding and demonstration. 2026 to 2027 is when we'll see fault-tolerant quantum systems that can run for extended periods of time without losing coherence. By 2028, there would be commercially available quantum computing services for specific applications. Cloud-based computing processors would also be available, which you can access for chemistry simulation, optimization problems, and machine learning in general. Finally, by 2030, quantum classical hybrid systems will become standard in research institutions. Every single major university and research lab will need to spend hundreds of thousands of dollars to get these computers. But when we reach 2030, we will enter a territory that is difficult to predict because anything can happen. Maybe we'll see advanced general AI, quantum thermodynamics engines, that can create almost anything that seems magical by today's standards. Here's our choice. We can either watch this unfold from the sidelines, treating quantum as someone else's problem, or we can engage now, develop quantum literacy, and position ourselves to benefit from the biggest technological shift that is yet to come. Subscribe to the channel if you don't want to miss what happens next with the quantum revolution.